Section 13.6 is about circular functions, and that's about defining sine and cosine in terms of the unit circle. So here you see an angle that we've moved around from the initial side to the terminal side, and that angle touches the unit circle at a point. Well, it so happens that that point has the cosine as its x value and the sine as its y value for the angle here, theta. Because remember, this angle that I have in red here has a reference angle in green that's from the terminal side down to the x-axis. And again, cosine of that angle is the x and sine of that angle is the y. Now it's also important to realize where your angle or where your terminal side is located. If the terminal side is located in the first quadrant, you're going to have a cosine and a sine value that are both positive. But if your terminal side is in the second quadrant, your cosine will be negative and your sine is positive because you know about ordered pairs that exist in those quadrants. In the third quadrant, cosine and sine are both negative, and in the fourth quadrant, cosine is positive and sine is negative. Now let's see this idea in action. If we're given a terminal side that you see here in blue, and it contacts the unit circle at this point, and the point is these ordered pairs, then we're asked to find the sine of theta and the cosine of theta. Well, the reference angle is right here, so that's also the value of theta. And from the property here, from the definition of sine and cosine, we know that cosine is the first number. So our cosine is 2 root 2 over 3, and our sine is negative 1/3. That fits what I just showed you here, that cosine in the fourth quadrant is always positive, and that sine in the fourth quadrant is always negative. Now from this definition alone comes one of what I think is the coolest things in all Algebra 2, and that is this. This is the unit circle, and using the property that we just talked about on the last slide, you can see that some special angles are given here, not only in degrees, but the radian measures are given, and their cosine and sine ordered pairs are given. But I want you to notice something. For a 30-degree angle, 30 degrees is also the reference angle of 150. Now compare the cosine and sine of a 30-degree angle and compare the cosine and sine of a 150-degree angle. Notice they're the same, except the cosine is negative, which we said because in the second quadrant, the first value is negative and the second value is positive. Notice all of the values that are in the first quadrant are repeated as you go around the unit circle. The only thing that changes is the signs. So you can use the unit circle to find sine and cosine of many, many angles, whether they're in degrees or radians. Now on this side, you see what we call the sine curve and the cosine curve. This one is the sine curve, and this one is cosine curve. And they're called that because the curves are created from the values of sine and cosine as we start at 0 and go to 360. In much the same way, it's the same information that you see here as you start at 0 and work your way around the circle to 360. The same values that you find here on the unit circle are the same values that you find on the sine and cosine curve. It's just when you put them all next to each other, they make this nice curvy thing. Now I want you to notice that the value for sine and cosine repeat. So once it gets to 360, it goes back up and it starts the progress of going up and then down again. Same thing for cosine. Once it gets to 360, it starts to work its way down, and it just becomes this, this curve that looks like this. We call that a function that is periodic. Both of these functions are periodic. They're periodic because they both repeat every 360 degrees, or they repeat every 2 pi radians. So now that we understand sine and cosine as part of the unit circle, we can find the cosine of 675 degrees without a calculator. So I'm going to take cosine of 675. I'm going to start with a 675 degree angle, and I'm going to subtract 360. Now why I'm going to do that is because I want to find out what the angle is going one time around the circle. So if I do this, I get 315. So we're really trying to find the cosine of a 315 degree angle. Well, if I go to my unit circle and I make my initial to terminal side here's 315. There's the angle that I'm looking for. I want to find the cosine of that. Well, notice what the reference angle is. Here's the reference angle on my unit circle. To get from 315 to 360, that's a 45-degree angle. So that's my reference angle, which means here's the angle that I'm looking at, which also means here's the cosine and the sine. So because I wanted the sine value, I'm going to look at square root of 2 over 2. But remember, got to make sure we go down here and look at it. Square root of 2 over 2 in the fourth quadrant is still positive. So the cosine of a 315-degree angle is square root of 2 over 2. So go back here and I'll say cosine of 675 is the same as the cosine of a 315, which is the same as a cosine of a 45, which is square root of 2 over 2. Likewise, sine of negative 5 pi over 6. Well, if I take negative 5 pi over 6 and I add 2 pi to it, then I'll just spin it around the unit circle counterclockwise and find out what the positive version of that angle is. So this will be a 6 over 6. So negative 5 plus 12 is 7 pi over 6. So that's really the angle that I'm looking for is 7 pi over 6. Here I'll go back to my unit circle and I'll see that 7 pi over 6 is right here. That has a reference angle right here of pi over 6, which is this one. And therefore I'm talking about these two values for cosine and sine, but cosine and sine are both negative in the third quadrant. So I'm looking at 1/2 for my sine, which would be negative 1/2 for a 7 pi over 6 angle. So the sine of negative 5 pi over 6, which is the same as 7 pi over 6, which is the same as pi over 6, is negative 1/2.